record, and we're good to go. And then another housekeeping thing, if any of y'all notice that I'm not recording, if you remind me in the first 5 minutes of class, I'll give you an extra credit point, but I really don't want to not record, but I tend to be a little forgetful with that. So that'll be an easy way to respect your credit. All right, so let's go ahead and start talking about what is human factors engineering. One of the neat things about this class is it's a mix of psychology students and of engineering students. And that's because that's what human factors really is. It's an intersection of engineering and psychology. You're really trying to make technology or systems work for people. Now, human factors engineers do stuff more than just with technology. We'll get into like organizational design, personnel selection, stuff like that. But my particular interest is in the use of technology and the interaction with the human. And so to give just a couple examples, you know, I said I like Apple products so much better than I like, in this case, PC or Windows products. But that's because a lot has gone into establishing that sort of brand loyalty with Apple, but also with the actual human factors of it. And so one of the things you may notice if you are an Apple user is that you pick up one device, and it's a seamless transition between device and device. One of the things they really try to make easy, you pick up your iPhone, you can immediately hand off whatever you're doing to your laptop, so it's a seamless integration. I have, I've got iPad, iPhone, and then Apple MacBooks and iMac. And the really nice thing is they've also created these sorts of ways in which you can interface between them, not just in the handoff map. So I've got, with my iPad, a feature called Sidebar. And so I can turn it into a whole other desktop just by plugging it there and switching back and forth between the functionality. Now that in and of itself is not really all that impressive because those functionality things exist on other platforms. But one of the things that Apple does really well is it makes it kind of idiot-proof. You can pick up an Apple product, and when you want to be able to do something, you just try to do it. And most of the time, just trying to do something, if you don't know how to do it, is good enough. It'll at least get you a foot in the door to figure out how to do that. And so you may have experience when you want to delete an app. All you have to do is hold down on the app, and it gives you a whole bunch of those options for what you can actually do with the app. The nice thing about that is you kind of stumble into that whether or not you're trying to delete an app. And so one of the things you may have happen, you pick up your phone, you leave your phone or your thumb on the phone, and all of a sudden a whole bunch of features pop up that you didn't know you had. So they kind of make it easy in the sense that you're learning without having to go through a specific declarative process how to delete those apps. But you also just have certain intuitions, okay? If I want more information about something, I'm just going to click on it. Okay, well, clicking on it didn't do it. What if I hold it down? So you get this really intuitive process for how to navigate these different platforms. And it's not just Apple that does this. I mean, all the different carriers have really tried to make it seamless for any sort of interfaces with their devices. One of the most amazing things, though, I think about human factors engineering, is that despite the fact we know that the human should be considered, despite the fact we spend billions of dollars on user experience, on the educational aspects, you still see profoundly stupid decisions that are made because they're not considering the human. And so what y'all see here is the F-35. So that's the brand new stealth fighter. It's supposed to be, you know, across the different branches, but there were certain design challenges that proved that to be impossible. However, once they finally got to the point where they were releasing it to the Air Force, it's this multi-billion-dollar aircraft. The helmet itself costs $600,000. It's custom fit to every pilot, so you can't reuse the helmet. It's got a whole bunch of integrated system technologies. The problem is they're spending all this money on development. They're creating this really cutting-edge fighter aircraft. But they didn't think about the fact that the helmet was so heavy that upon ejection, it would snap the pilot's neck. Kind of defeats the purpose of having an ejection seat, right? If you're going to just kill the pilot on ejection. What was that?
Or having a helmet.
Yeah, exactly. Yeah. And so they had to go back and redesign the system. Now you can think, if a helmet's so heavy it's going to snap a pilot's neck when they eject, it's also got to be pretty uncomfortable after sustained wear. If you've ever worn a really heavy helmet, that kind of taxes your neck, gives you a lot of spinal pain. And so you can think about the fact that even though we had the best and brightest minds working on this technology, we still allowed it to get to the point where people just fail to consider the very fundamental things about a human, like the musculoskeletal system, that should be considered. You also get advances with things like, this is the HTC Vive, so any virtual reality headsets. There's been an issue for a long time where people get what we call simulator sickness, or VR sickness, wherein after sustained periods in the VR headset, the virtual reality headset, people start feeling nauseous and dizzy, sick. And one of the things that causes that is a discrepancy between the visual information that's hitting your eyes and the information received from your inner ear. And we'll go over the actual proprioceptive and kinesthetic feedback later on in the semester. But one of the things I realized is if you can minimize the amount of movement associated with gameplay, but still allow people to navigate in a complex environment, then may be able to reduce some of that simulated sickness. So what they did is with these little hand controllers, whatever you call, they allow people in a lot of games to now just kind of highlight an area they want to go, and it leads them forward. It flashes the screen on, flashes it back on, and now they're in that place. So you don't have this discrepancy anymore between the visual information saying you're moving, but no haptic information, no proprioceptive information from your inner ear saying we're not moving. And so by removing that discrepancy, you're now able to deal with one of the biggest contributors to those simulator sicknesses. So there are three primary focuses within human factors: safety, performance, and satisfaction. So safety is fairly obvious, right? How can we design an environment? How can we design a system to reduce the risk of injury and death? Some of these are, kind of what you would expect to be common sense. You don't want a slick floor when people are carrying heavy things, or even in general. What are the harnessing requirements that we're going to design into the system, etc. You then have performance. And so performance is a little bit more complex in the sense that you have to kind of define what it is that we're talking about when we talk about performance. Now, one of the things could be increasing productivity. And so perhaps, we own a widget factory, and what we're really trying to do is get every employee to output as many widgets as possible per hour. It could also be a quality thing. So maybe we have too many of these widgets that are, they're being made really quickly, but they're not being made of a high quality. And so you actually saw this early on with Tesla manufacturing. Tesla opted for automated robotic arms to help with the assembly process. And then they started getting in trouble a little bit because people were getting these vehicles that frequently cost over $100,000 with not great tolerances of the vehicle. It looked just very sloppily made. And so Elon Musk himself, to his credit, said, yeah, I screwed up. We shouldn't have been using the robotic arms. And there's something to be said for having the human in the loop. So thinking about what are those design approaches that enhance the quality. You can also think about efficiency. So maybe it's not just number of widgets, but it's how efficient are you being. And so one of the things you see with companies like Amazon is they realize that every second that a worker is not working on packing boxes is time lost. And so now, instead of having the workers go from shelf to shelf, pick up things that they need, they literally have robotic parts that bring the shelf to them. So they can just stand there and continue to pack boxes time and time again. However, the third thing is satisfaction. And so you can think about satisfaction from either the consumer's perspective or the employee's perspective. You know, what I just described from Amazon has led to a lot of Amazon employees being really dissatisfied because there's so much emphasis on stand there and pack, that they feel like, A, it's almost impossible to actually meet the quotas that are expected of them, but B, it's so monotonous that they kind of lose any interest in the actual product itself. And we'll talk about job satisfaction in the semester. But then you can also think about the job or the satisfaction, of the consumer perspective. So what is it about Apple that really makes me enjoy the Apple experience? Generating that sort of ecosystem. And so the prioritization of these three different things depend on the domain, obviously, right? So high-risk domains, our primary interest is going to be safety. Perhaps at the sacrifice of both performance and satisfaction. So maybe what we really care about in let's say, a manufacturing plant, we want there to be some output, right? We have certain expenses we need to be able to cover. And we want people to be happy, but what we don't want to have to do is pay a lot of workers' comp or get such bad press for poor safety issues. A general workplace, you're going to want to promote safety, but above all else, you're going to really want to focus on performance. Right? I've got stockholders that I need to be able to answer to. Now, it's when you don't get that right balance between safety and performance that you run into a lot of the PR issues that companies have run into. And then with consumer products, primarily what you're interested in is satisfaction. Right? I will be the first to admit that while I love Apple products, they are far from the best that are out on market. Right? There are a lot of companies that are pushing the boundaries further. They're doing a lot cooler things, a lot more impressive things. But I'm so satisfied that I've accepted kind of a diminishment of performance in exchange for an increase in that satisfaction. So we're going to skip this because it took me forever to figure out how to work the technology today like an old man. Oops. Why is the tool? That's ironic that as soon as I say that, I struggle to even get the slides to do it. I guess it's not skipping, it just looks like it's skipping. Never mind. All right. So why do we even need human factors engineers? Well, we'll show some examples later in class today, demonstrating that you can't rely on your intuition, despite what people want to believe. You're really having to establish what is the trade-off between those three goals. You know, it's not always possible to maximize performance and safety. You know, we can talk about things like establishing ROC curves, so receiver operating characteristic curves that allow you to evaluate the trade-offs and things like performance. We'll do that later in the semester. But really, you're going to have to try and work to find that right balance. Part of it may be dictated by the customer, whereas other parts may be dictated by your own intuition or a certain moral obligation that you feel like you have. And so when we talk about the human factors design process, it's rarely just a linear, holistic process. It's frequently iterative, right? So you create a solution, you evaluate that solution, you try to understand how that solution fits into the environment, and then you recreate it. It's continuously iterative. And so when we have our guest lecturer, my friend who currently works at Open Table, she'll talk about some of these different processes, design processes that they use. But to kind of preview it, you may have noticed that frequently when you download an app or a program will say, you want to send reports to this company. If you say yes, what happens is they'll release some sort of update, they'll download that update, and they're collecting a whole bunch of performance metrics, both in your use of the system, but also the system performance metrics that go back to this company that then allow them to reiterate, right? So now they can have a new creation, a new bug fix, a new sort of design implementation that they can then evaluate from that data. I'm going to pause real quick. If anybody has any questions on Zoom, feel free to either unmute yourself or type them into the chat box. Anybody here? So for those of you all here in person, are you psych or engineering or either? Engineering? Engineering? Awesome. Grad or undergrad? Undergrad. Cool. Who are you working with?
PDX.
Oh, I'm sorry. Who in the engineering department? Do you have an advisor?
Oh, Dr. Nesser.
Oh, awesome. Great. I just got off the call. Talking a lot. All right, no other questions coming in, so we will continue to push on here. Am I crazy or does it look like it's interview? I swear to God, the start of the semester, I think it's throwing me off here. All right, so when we think about the actual iterative process, there are kind of different time scales, there are different approaches to the actual overall evaluation and understanding of the problem. And so it frequently starts in cases like accidents with an accident investigation. So at the end of the day, we'll talk about Asiana Flight 214 that crashed in San Francisco back in 2013. And some of the things that the NTSB established in that accident investigation led to that overall accident. It can also be observation. So maybe you're just brought in to observe and see, okay, what are the inefficiencies in the system? Or you can perform a task analysis. And so you're actually breaking it down and seeing, okay, what is somebody actually doing? And how can we make that either safer, more satisfying, or increase the performance? And so we'll talk about the different kind of solutions, the different creations that you can bring into the loop. So that includes task, equipment, environment, training, selection, organization solutions. All right, so one of the things I see a lot in working with engineers, not pick on engineers, is that engineers always want to look at the equipment, right? What solution can we design to just answer the problem? Psychologists, on the other hand, tend to get so focused on the individual and not the solution. So psychologists tend to like to say, okay, well, let's just train them. And in reality, it's rarely the case that either one of those is specifically the only answer. And so looking at the interactions between a whole bunch of these things, including the systems as a whole, those would be all systems in here. And after you create that solution, it's not enough to just say, okay, we're done. Right? You have to go through that evaluation process. You go through things like a heuristic evaluation. So a heuristic evaluation is you have a certain amount of information in your head because you take a human practice class or you have your degree, and you're brought in to say, okay, based off of what I know, this is good, this is good, this is bad, this needs work in these sorts of ways, this could be slightly improved, etc. Right? So heuristic evaluation is just kind of an expert evaluation. All right, looks like Isabella, you said your audio is a bit poor. Have others been able to hear me? Try turning up the volume here.
I can understand you. It just seems like you're in a large room, maybe. Well, I mean, oh yeah, you're in a large room, or I don't know if there's just the, yeah, the echo or feedback.
Can enunciate through the mask. Yes. How about I just hold this up and see if that works? I'm going to try not to blow out the eardrums of people in the class here, though. So, all right. Let me know if you're still struggling with it. If so, I have a face shield that I can wear instead of a mask. It makes me feel like an astronaut. I'm not sure that's really what I should be focusing on. Small stuff for me. Exactly. Yes. Yeah, I'm doing my part with that coronavirus astronaut need. Probably be way better. All right. Just for you, Sherry, I'm going to go into astronaut mode. I feel like I should clip this under the all right, how are we doing now, Sherry? Can you hear me? You just need a spacesuit. Yeah, if anybody wants to go over to the Space and Rocket Center and get me one of those children's-sized spacesuits, I'm happy to put that on. All right. Thanks for letting me know. All right, so yeah, we have the heuristic evaluation that we already talked about. An actual one word. Bring it to me, Kelsey. No extra credit, but I'll steal it. You also have the usability testing. And so that's us taking the product and putting it through the rigmarole, right? We are seeing, okay, what is the task that you want to be able to accomplish? And how capable are you at accomplishing it with the current design, the current layout? So how many clicks does it take to find what you're looking for? How efficient is the system? We're looking really at those sort of performance metrics. And then you have the whole system evaluation itself. So whereas the usability is focusing kind of more on the human side, the system evaluation is going to be focusing more on the overall integration of that design solution within the greater whole of that engineered system. And so the cycle takes everywhere from minutes to years, right? If you look at a lot of these accident investigations, the accident investigation itself often takes usually at least a year. Right? There's so much information that they're sorting through. And then once you have that understanding from that accident investigation, it takes a long time to create those solutions and evaluate those solutions. So one of the things y'all may have seen is the aviation department in Boeing has been really struggling with the issues of, what is it, the 747, I think, that was having the power loss issues. And last I heard, now coronavirus probably put a damper on that, but last I heard, they were still struggling to be able to get the solution, the interior solution, back to market, right? So we'll talk about, again, some flight or some pilot issues that could be at play anytime you have this sort of airline accident. But it's not always the case that a creation of solution is going to be immediate. And then once it does happen, you have to go through all of this testing to make sure that not only does that engineered solution not impact the rest of the system, but it doesn't also have second or third order effects on the human itself. Right? The helmet seemed really good in the F-35. That's because all the testing was done probably in a static chair for short periods of time with people that were not under G-loads, right? So thinking about, okay, what are the second and third order effects of these designs? All right, so like I said, we have task design, equipment design, environmental design, training, selection, team, and organization design. So, starting with the task design. A task design solution is changing what the operators actually do. So let's say in my widget shop, we've had a lot of issues with low back problems. And we've decided that based off the data, it's probably from lifting this one heavy piece of raw material. And so now what we're going to do is make sure that the operators don't actually have to lift that heavy or raw material. So the designing of a robot can fit in with this task design, but it'll also fit in with the equipment design in just a minute. But also thinking about what are the efficiencies or inefficiencies in the way a task is actually completed that we can change in order to enhance it. And so you all may be familiar with this kind of idea of the Ford assembly line being the precursor for the kind of mass consumable car, right? They were able to get the price down on each individual automobile to a point where your average middle-class family could now own a vehicle. And that derives largely from Ford's kind of mimicry of a man named Frederick Taylor, and this kind of whole philosophy of Taylorism that focused on what are these minute inefficiencies that we can redesign in the task to enhance the overall performance of the system as a whole. And so what Henry Ford did is said, okay, instead of having your individual assembly line worker work on the vehicle from the first assembly of the bolts all the way through it rolling off the assembly line, they said, okay, your specialty now is just going to be all the rivets in the passenger side door. So that's all you do. With the idea that you become so good and efficient at that, that we can now enhance the overall efficiency across all of the assembly line to reduce that cost. We'll talk a little bit later about the obvious second and third order effects of that. Obviously, if your design or if your task is to put in the rivets in a passenger side door every day, 9 hours a day, for 45 years, chances are there's going to be some poor job satisfaction. And so we'll talk about some of the neat solutions that companies come up with nowadays. But it's why you also see a little bit more complexity in the actual job task requirements for assembly line workers today. Equipment design. So this is one of my favorite horrifying stories of all time. I think this was in France. Yes. So a civilian got a ride along in a French fighter aircraft, and on takeoff, accidentally ejected himself from the aircraft. And they think what happened is he was bracing for takeoff and reached under his seat to grab onto something, just to brace. And what he grabbed onto was the ejection handle. They had placed the ejection handle in such a location that somebody who wasn't all that familiar with the operation of the aircraft could mistake it for just a sort of structural bar. And so clearly, you then have to redesign a system to make it such that you can't accidentally eject yourself, right? We'll talk about other sort of displays and control configurations later in the semester. But if you have a really important switch, you don't want to make it really easy to bump. For example, over here, I don't know if people on the camera can see, well, we've got a lockdown button. I guess that would be an active shooter or something like that. But they put a glass covering over it. They still want me to be able to hit it really easily, but they don't want me to back into it, especially with it right behind the computer. So what are the equipment design solutions, like creating a robot that'll help with the lifting of heavy materials that we can bring into the fold? You also have environmental design. So have any of y'all been to Vegas or Atlantic City? No? Well, if you ever go, one of the things you'll notice is that the casinos themselves are housed in these massive, well-lit rooms with no windows and no clocks, loud noises, really bright fluorescent lights, because what they're trying to do is trick your circadian rhythm. Your circadian rhythm is the part of your brain that says, okay, it's bedtime, go to sleep. And they figured that by putting people in this room with no indication of the actual time, there are no clocks, but by increasing the amount of blue light in that room, they can reset your circadian rhythm. This is why you see all those red light filters on phones, on computers now, because we understand that blue light, higher energy light on the visible spectrum side, will reset your circadian rhythm such that it makes it harder to fall asleep. And so they just pump in a lot of blue shifted light into these rooms. There are also rumors, and I don't know if this is true, that they'll also pump in oxygen to try to manipulate folks there. Now, it's not always the direct manipulation. You can also think about, okay, what are the things in the environment that we need to address? Is it a really noisy environment? As we'll talk about later in the semester, it's not just the energy level or the decibel level of noise in an environment, but it's the interaction between the decibel level and the amount of time you are exposed to it. You also have training solutions. So some training solutions involve task-specific aspects. Some will be general knowledge and skill. Right? So when we think about the military, one of the things that comes to mind for most civilians is the idea of boot camp or basic training. Right? The goal for a lot of these basic training across the globe is to take somebody from citizen to soldier, right? Building them up from the base level to teach them how to be a soldier, a sailor, an airman, marine, etc. You can also think about, this is, I think, the ride simulator over at the engineering department. What are the things in which we can or should be training people before they get out into the actual real world? And so one of the things that kind of precipitated this simulator here was the idea that maybe we can train big rig drivers, 18-wheeler drivers, how to drive and how to navigate before they actually get into a massive truck. Right? You want to be able to learn how to navigate city roads before the first time you actually have to be on city roads. Right? So what are the things in which we can design, or what are the environments in which we can create an educational experience for the individual to get them better at their job before they actually have to go out and perform their job? And this was kind of the inspiration for, I think the Navy is also doing it, but the Air Force's, what is it? Next generation pilot, or pilot next gen, or pilot gen next, or whatever it is, some combination of those words, where they're trying to train pilots on virtual reality headsets rather than putting them right away into aircraft cockpit. It's a much cheaper way to train each one of these pilots. I don't remember the exact number, but when I was at the Air Force Academy before, I once heard that it costs, on average, I think about $4 million per pilot to train them. A combination of the aircraft, the fuel consumption, the pilot time, or the training pilot time, etc. And so what are the things in which we can derive from the commercial market, like virtual reality headsets, to actually get them squared away and ready to go? You also have selection solutions. So changing the makeup of a team or organization by picking the people that are best suited for that job. And so when we had my friend at the end of the semester coming to talk about his recruiting work and kind of his approach to recruiting within Facebook, he will likely talk a little bit about these selection criteria that they go through. Right? You all are familiar, at least peripherally, with this idea, having to take the GRE or SAT to get into grad school or undergrad. It's the idea that it is a selection criteria. It allows us to see, okay, who has the base knowledge, which is indicative of an ability to excel here at UH. But you'll also have things like evaluations of personality. So maybe, in a sales position, what we really want is an extrovert. We don't want an introvert who's going to get exhausted by the idea of constantly interacting with other humans. And so one of the things we can do is issue personality tests to all of our employees and see, okay, what are the factors of those personality tests that predict which employees are the best employees and the worst employees in our company. The single greatest predictor of success at the military academies is this construct called grit. And grit is essentially your ability to persevere in the face of adversity. Are you willing to keep going, or do you kind of shut down? Right? So what are those individual differences that predict success in an organization, at an institution, etc.? You also have team and organizational design changes that can be made. And so this is including things like changing how groups of people communicate and relate to one another, changing the work or organizational climate, so when I went to go visit my friend at Facebook, one of the incredible things when I got there that I didn't really have an appreciation, you always see things like the ping pong tables and the cafeterias, etc. But Facebook has done an amazing job making it essentially a little city that you could, in theory, never leave. Right? They have everything you would need, including food, or daycare for kids, laundry services, everything you could ever want, including arcades, woodworking shops, gyms. They even, on one of these buildings, I don't think it's in the picture, but on top of one of the buildings, they've literally created a park. They brought in dirt and grass and trees, and on top of the building, in the middle of the Bay Area, you can just go on top and enjoy a respite in a park with your offices right below you. They have things like places to nap, private phone booths. And they do this for a multitude of reasons. One, they're competing with other big tech companies, right? They want to keep the best and the brightest at Facebook rather than losing them to Google or Apple or OpenAI or any of these other big tech companies. They also want to make it such that you don't really have to leave work. Right? One of the biggest motivators for a lot of people, when you talk to them, of why they're going home for the day is, I'm hungry, I want to get home, have some dinner, and then I'll get back on the computer when I get home. Or, I want to go to the gym, and then I'll get back on the computer when I go home. But Facebook's done it that you can just do all that here. You can have the laundry done for you while you work. Your kid can be taken care of while you work. Right? So they're really trying to make it such that they're attracting good talent, they're keeping that talent happy, and they're preventing that talent from leaving. Because it is so expensive for them to backfill these other positions. also think about just the organizational aspects of if you're really trying to be cutting edge, maybe it doesn't make sense to have everybody be siloed with only their teams. Maybe you want to create these environments wherein I can go play ping pong with the software engineers who are working on certain aspects, let's say the marketplace, and create these clever ideas. That slide's out of place, as is that one, as is that one. Sorry. All right, so this really serves to highlight what I was talking about at the very beginning of class. That when we talk about human factors, human factors at UAH, I'm housed in the psychology department. I have a lot of friends who are human factors engineers who are in engineering departments, some in computer science departments, kind of all over. So human factors really does, because it's so applied, try to pull from all these different disciplines that you see up here in an effort to establish the best ways in which we can do things. Human factors is not a psychology discipline. It's not an engineering discipline. It really is cross-disciplinary. So this will probably be more useful for those of y'all in psychology rather than the engineering department. But it's really important to think about these systems holistically. I'm sure this is something that's beaten into y'all a lot in systems engineering. It's the idea that you cannot think of your solution in a siloed, isolated way. You have to think of things like interconnection. So if I change one feature, what does that affect down the line? Things like adaptation. So people adapt to technology, and I think that's supposed to mean bad outcomes rather than bad outcomes. But think about things like self-driving cars. Right? So Tesla now has a vehicle that can pretty well mostly navigate itself from point A to point B, but is not really great at dealing with all the pop-up issues that come up with everyday driving. Right? So you get a lot of people who become really complacent doing things like reading books or watching movies, etc., while behind the wheel of Tesla. And then the vehicle fails to recognize things like stock fire trucks, which has been a remarkably recurrent issue for Tesla. And then you crash, right? Because you've become complacent, you had this diminished situational awareness, and now you're not being able to supervise the technology. Right? So you've increased the technology with the idea that you're making it safer, but now you've introduced new unsafe interactions between the human and the system that didn't exist before. You also have to think about the environment. Right? The environment really guides our behavior in everyday life. So when you see this on a door, what does that tell you? Push, right? That plate serves no functionality. Every door would be equally as functional without that plate. And you don't even think about it when you go to those doors, right? Each one of y'all, as you leave, are going to push these doors open because they have the push bars, right? You're not going to think about it. You're just going to push. It serves no purpose other than to indicate to the individual how to interact with the object. So it's not only telling you to push, but it's telling you where to push, so you know which side.
So one of the most common things I get when we talk about human factors engineering itself is, okay, this is just all intuitive. Obviously, we can intuit the right answers. I'm a user of the product. I can tell you what the actual answer should be. And so let me show you 3 examples, start from right to left. On the right-hand side, you have a can that says recycle in big letters on the center, and then it has openings for both trash and recycle on the top. Right? So at a quick glance, somebody's looking for the trash can, they're going to see that, they're going to read the big letters first that says recycle, and they're going to say, okay, that's not a trash can, we can move on looking for a trash can. But in reality, it serves the dual purpose, right? So somebody intuited that that would be sufficient, right? We can have both trash and recycle, but we're going to really let people know this is where you can recycle in addition. That's less egregious, though, than what we have in the middle. We have a handicap ramp in the middle with 2 stairs to get up. Kind of defeats the purpose of a handicap ramp if you have stairs to face them. Right? Nobody in a wheelchair is going to be able to overcome those 2 steps to be able to use that handicap ramp. But alas, somebody intuited that that would be a sufficient approach. Now, on the furthest left, I think, is the most subtle example of this. Do any of y'all have any indication as to what may be wrong with this design? Yeah.
Well, the 2 small burners not in the back, 2 big burners not.
Yeah, so you have a little bit of a mismatch there, wherein you have big burners at the corners and small burners at the other corners. Anything else? Or those on Zoom have any indication? What's that? Yes. Yeah, that's one of the biggest things, right? So we think about stovetop fires. What's the first thing you're supposed to do? You're supposed to turn off the source of heat, right? So if you have a fire in your stovetop, how are you turning off the heat? You have to reach through the fire to get to the control knob. That's additionally complicated by the fact that the control knobs are not really indicative of which surface they control. It looks like they may have little indications underneath, but that's now forcing you to look at that representation, make a 3D mental rotation of that to the stovetop, to then be able to turn off that knob as the fire is raging. And I'm sure if any of y'all have a stove like this, as was the case with me when I did have a stove like this, you would wonder why your pasta wasn't boiling, only to come back and realize that for 20 minutes it's been sitting on a cold burner while the one next to it has been hot. And so it's the actual mapping of control surfaces to the real world things that they control. We'll talk about controls later on in the semester. But again, this stovetop design is incredibly prevalent. In fact, I'd be willing to bet that some of y'all in this class still have new stoves with something similar to this. I also love it because a lot of times we think about psychology as being very intuitive as well. We think, okay, I can understand what we should be doing or how we think about this just by self-introspection. And to highlight that that's not the best approach, I want to highlight some of these contradictory aphorisms. An aphorism is just a kind of a meaningless saying that, or not meaningless, but a saying that we've kind of ingrained into society. So for example, we say that absence makes the heart grow fonder, but we also say that out of sight is out of mind. Right? Those are very contradictory. We'll tell people to look before you leap, but he who hesitates is lost. Again, contradictory. A penny saved is a penny earned, but don't be penny wise and pound foolish. Haste makes waste, but a stitch in time saves 9. Birds of a feather flock together, but opposites attract. This one drives me nuts. You'll hear this all the time when your friends talk about significant others or matching people up. say, of course they're perfect together. You know, birds of a feather flock together, or opposites attract. Well, now we've encompassed pretty much everything except for, they're kind of okay. We also say the best things in life are free, but there's no such thing as a free lunch. Right? So this serves to highlight that humans are really good at coming up with sayings that explain things without any real grounding in truth. Right? We can come up with sayings that contradict each other, and without hesitation, say them in the same day, or sometimes in the same sentence. So I would encourage y'all, as we go through this class, and we talk about things that seem, well, yeah, that's obvious, to think about, okay, it seems obvious because we know the answer, but what are some of the potential other explanations that we could have? What do we think about might happen if we had no understanding about human automation interaction that could explain patterns of behavior? This is also one of my favorite quotes ever, let alone for human factors. I'll just go ahead and read it out. So your customers don't care about you. They don't care about your product or service. They care about themselves, their dreams, their goals. Now they'll care a lot, or they'll care much more if you help them reach their goals. And to do that, you must understand their goals, as well as their needs and deepest desires. Right? So frequently on the industry side, we say, we have the product that's going to solve all your problems. Problems you didn't know you had. Look how great this product is. But in reality, unless you can hammer home exactly how that product is going to affect the individual, they're not going to be interested. And that means one thing for the consumer, but it means a whole other thing for you, the human factors engineer, when you go into these companies and you create a good solution, a great solution, that you now have to get buy-in from the employees. I often think back to a project I was on for the Air Force trying to revamp part of their mission planning technology. And you talk to some of these airmen who had been in for 10, 15 years, and they said, yeah, the system we're using sucks, but I know, I don't remember even learn something else, right? And so you're overcoming this kind of apprehension to new designs. And really, your best bet is to say, okay, why is this going to matter to you? To the CEO, it may be a monetary explanation. To the worker, it may be an efficiency or a satisfaction, right? You really have to make all of these solutions personal to get that sort of buy-in. We're running out of time, so we'll skip that. Yeah, so folks in human factors work kind of across the board. Really anything that you can think of from academic, like what I do with research and teaching, government. So the government is a big employer of human factors folks. You can think about military equipment design, system design, website design, right? What are the things that we need to be able to do, and what's the most efficient way to do it? In industry, I mean, again, you have things like website design, product design, T&E, test and evaluation. And I've got friends currently who are working at Facebook, Lockheed Martin, and other defense contractors, NASA, Apple, DirecTV, Microsoft, Navy, Air Force, Army, etc. Right? They may call it various things, and sometimes they'll call it user experience, sometimes they'll call it human factors. Sometimes they'll put it under the label of a systems engineer, but really what they're looking for is the human side systems engineer. Right? And so having this sort of background makes you so much more marketable when it comes time to go out on the market. I'll skip that. This is a really interesting link. We're not going to show it right now, But I want you to take a look at it when you get home and really try to understand why we're not at the point where we have fully autonomous cars. Right? Elon Musk has been promising that next year we'll have fully autonomous cars for I think the last 5 years now. And he said I think at one point he was on a podcast, I think called the Artificial Intelligence Podcast, wherein the host Lex Friedman asked Elon, why don't you have any sort of driver monitoring cameras? Aren't you paying attention to what the driver's doing so you can tell if they're just zoned out, right? That helps deal with some of the problems associated with running into the back of fire trucks. And Elon's response was, it's moot. It's totally moot. His point being, the cars are they're almost there. So don't worry about the human. Well, that was, I think, a year and a half, 2 years ago. We're still not there, and we're really not all that close. And so this video gives a really good kind of representation of a lot of the difficulties associated with making a car fully autonomous. I am going to show this video really quickly. Stop that share.
If my man was wearing this, I would be all over him.
It's an ad video.
That smells really good.
Car crashes are an all too frequent reality of modern life. But your chances of being in a plane crash are minuscule. On Saturday, the improbable and unthinkable occurred at San Francisco International Airport on a Boeing 777. More than 24 people remain hospitalized. And tonight, ABC's David Wright takes us inside how this could have happened and the tiny flight attendant who saved lives by carrying passengers twice her size off the plane during the crash landing in San Francisco.
To San Francisco Tower, runway 28 right, clear land.
7 seconds out, a final burst of speed. The pilot of Asiana 214 must have realized he was coming in too low and too slow when his controls literally started to shake. An automatic warning 4 seconds out. Then this. Go around, he says. Just 1.5 seconds before his tail hits the tarmac. Too late to save Asiana 214.
Oh my God, that's scary.
They're running out.
The emergency chutes deployed, the passengers sliding down, filmed here by a horrified family watching from the terminal building.
Everybody's just running.
The first major plane crash in the U.S. in 4 years. A life or death drama that dropped out of the clear blue sky. Moments earlier, on board Asiana 214, the in-flight between the exit row, headed home from a business trip. He looked out his window, suddenly worried.
I realized because I was sitting by the window that we were flying too low.
Up in business class, seat 3K, hip-hop producer Eugene Ross sensed a problem too.
I looked outside, worried with, with a little bit of, nervousness. And I could see the runway just right there, and plane was going to hit it.
The passengers say it felt to them like the pilot gunned the engine and pulled up, trying at the last minute to abort.
I don't know what happened. I was inside, but it certainly felt like we were going back up, and then we went back down pretty hard.
As I just grabbed whatever, and bang, the impact was so strong.
Asiana 214 belly flopped onto the runway and started to skid.
It was slow motion. I was like, I can't believe this is happening. I hope, we're going to be okay.
I thought I was dying, and I thought that was it.
214 heavy, emergency vehicles are responding.
So, pull this back up. So this is a really interesting crash for several reasons, right? And it highlights the complex interaction between human and system. So here is the abstract from the NTSB report. It won't go over all of it, but it includes things like operating procedures, design complexity, training, let's see, what else? Guidance on visual approach, manual flight, context dependence on certain alerts. And it's really interesting to think about what are the additional factors that maybe have nothing to do with flying that influence this actual crash. And so the number is going to vary from aircraft to aircraft, but you heard me talk about the go-around, right? So for those of y'all not familiar, a go-around is on final landing, they decide they can't make a safe landing, so they push the throttle all the way forward, pick back up, go back around, come back to re-land. In these big commercial aircrafts, that costs about $10,000 in fuel. So the decision made to go around immediately costs the airline company $10,000 on average to go around. Right? And that puts a clear incentive on these pilots to try not to do that. Right? I don't know what the actual reprimanding process would be for poor performance, but I have to believe that there is at least some fear that if you're routinely costing the company tens of thousands of dollars in fuel, that something bad may happen to your career. There's also been a really interesting discussion about the cultural impacts. So this is Asiana flight, so it originated, I think they said from Korea. And it was two pilots, a more senior one, and a more younger one, as you typically get in the cockpit. And reports indicate that the younger pilot actually noticed that something was going wrong. But because of kind of the cultural mores against correcting your elders, he refused to make any sort of mention that he noticed something was going wrong, right? So this is a cultural problem. It's not necessarily a cultural problem, but in this case, it was a cultural influence on the crash. Obviously, given the NTSB write-up, it wasn't the only thing, but these are the sort of human-related things that you have to think about outside the scope of just what's going on. Are there power dynamics that are going to affect employer-employee relationships? And then you even see later on in the NTSB report, there's some confusion about the three, I think it was three fatalities from this accident. Whether those fatalities were actually in the aircraft or because they were hit by responding first responders. Right? There's some allegation that it was actually fire trucks hitting and running over people on the way to the accident that killed these people, right? And so now they're talking about, okay, what are the actual preparation drills or the guidance or protocols associated with responding in this case? And so we'll talk later on in the semester about things like UTLUF, which is out of the loop unfamiliarity, right? So if you have either a black swan event when it comes to automation, so something that almost never happens, or perhaps you have something like this, there's just never any airline crashes in the US, thank God, that certain response skills kind of go out the window. Right? So you can think about all the ways you have these human interactions with the system that dramatically impact it. All right, we're pretty much done there. So I'm going to open up, if y'all have any questions on Zoom, either unmute yourself or type them in the chat box if y'all have any questions here. Otherwise, I will see y'all on Thursday for the next lecture.
I had a question about the cultural differences that you mentioned affecting the co-pilot's ability to discuss the issues. Would companies consider that when they design a product?
Hannah Smithman, if you're trying to say something, I can't hear you.
Can Can you hear me now?
I cannot hear you now.
Okay. I was asking about
I can't
what you
hear
said.
you. I'm sorry.
Oh, you can't.
Of course. And it may be an issue on my end. So if you can type that in. How would companies analyze these cultural differences that make them into play? Yeah, that's a very good question. So it really helps, I think, to have cultural experts, or at least people from that culture or society actually giving feedback or insight into what's going on. It's also something that you kind of have to frequently just kind of observe, right? So it wouldn't be something that I think a lot of Westerners necessarily think about the cultural differences there. But in kind of observing interactions, you may be able to start picking up on those things. But yeah, I mean, it's a real difficult problem and difficult solution. It also, I don't know if this is totally true, but Chevy used to have a vehicle called the Nova, and it sold reasonably well everywhere except in Spanish-speaking countries, because Nova literally means no go. And so thinking about, okay, what are these sort of, cultural aspects that maybe we could benefit from having, an office or hires from these different regions and maybe able to provide insight into this that we don't have. Good question. All right. Have any other questions?
Can you hear me? Hello?
Yeah, feel free to unmute yourself, Dennis, or type it in.
Okay, yeah. Just testing. Can you hear me, Nate?
Well, I guess unmuting yourself seemed not to have worked earlier, so. Let's see here. Try again here, maybe?
Okay, can you hear me, Nate?
I can, yeah. Sorry.
Okay. I have heard, in my interest, I'm in the UX track, the grad certificate, and I'm looking to get on to Redstone Arsenal. And I have heard that there is some resistance, I think, with either the government or some of the companies out there, or a challenge for the UX departments to kind of sell it to the higher ups. And I thought maybe if you could talk about some of the challenges that some departments or human factors engineers have in trying to sell the value.
Absolutely. Yeah. One of the biggest problems I think human factors folks run into at every level, industry, government, academia, et cetera. It really boils down to, at least from my experience, figuring out what the decision makers, the customers, ultimately want. Like, what is their end goal? And then convincing them that your solution helps them achieve that end goal, right? And so if it's a monetary thing, show them how this increase in efficiency is actually going to save money, because you're able to either produce more widgets, or you're able to get better overall product, or you're able to get more kind of consumer buy-in from it. You know, in the case of the military, there was always kind of this whole adage, warheads on foreheads. You know, how are you delivering the most efficient warfighter to the battlefield? Yeah, exactly, the ROI. Yeah, so it frequently does come down to an attempt to convince whoever the stakeholders are that your solution is going to allow them to better accomplish their end goal. Because in reality, they're not going to care about human factors. I mean, just on an ethical, or not an ethical, on a sort of kind of a purist theoretical level. But really convincing them that your solutions are going to help them get whatever they want done better is kind of your best bet. Yeah, absolutely. It's a really good question. What other questions do we have?